Chapter 3, Section 7 is about impulse and changes in momentum. The chapter work is focused on crumple zones and why we have them. This video tutorial will focus on learning targets 3.7.1 and 3.7.2. First, let's talk about crumple zones. What is a crumple zone? Crumple zones are areas in vehicles where the materials are meant to bend and twist instead of stay sturdy. But why would we want crumple zones? Well, crumple zones are a feature of a car that functions to absorb the energy from a collision. They're part of the car that crumples under the impact, right, instead of stay sturdy, because that way they can spread the force out over a longer time. Spreading the impact force out over a longer time will cause less damage and less injury, especially to the people inside the car. So here's an example. This car has a crumple zone in the rear area. Notice that this whole area here has been damaged due to the impact, but where the passengers are, that area remains intact. So the goal of a crumple zone is to decrease the force that's acting on the people inside the car by increasing the amount of time that the force acts. By increasing the time, the acceleration is reduced. And if we remember Newton's second law, force equals mass times acceleration. If we can decrease the amount of acceleration, we then decrease the amount of force acting on the object. So think about it this way. If we have an object that has a 100 kilogram mass and it has an acceleration of 10 meters per second squared, it's going to have a force of 1,000 newtons. If we can lower the acceleration to half the amount, 5 meters per second squared, 5 times 100 is 500 newtons. We have now reduced the force by half. And remember, if we are increasing the time, that automatically decreases the acceleration, because acceleration is the change in velocity divided by that amount of time it takes. So by increasing the time, we decrease the rate of acceleration. And again, by decreasing the acceleration, we decrease the force. So another example of a crumple zone. Okay, we have the crumple zone in the front of the car. We have the passenger area remaining intact because the crumple zone absorbs the energy from the collision and reduces the force. Folding of the car increases the impact time. And as the amount of time is increased, the force is decreased. As we talked about before, all moving objects have momentum. Remember that momentum is equal to the mass times the velocity. The momentum can be changed by applying a force over a certain amount of time, right? We take unbalanced forces and that causes changes in motion. The impulse, what we call the impulse, is any change in momentum. So when we look at the information here, we have a force that acts over a certain amount of time. That's known as the impulse. Impulse is any change in momentum. So we have the mass, which we know remains unchanged. We don't take things away or add stuff to, but we can change the velocity. So by adding this force to change the velocity, we then can change momentum. So impulse and change momentum are equal. The impulse equals the change in the momentum. Okay, this is another way to look at it. The impulse applied by the net force gives you a change in the momentum. So the impulse is force multiplied by the time it takes to apply that force. Momentum change is mass multiplied by the change in velocity. So we can write impulse equals change in momentum. We can also write the equation this way. If we want to find out the force, we can take the mass times the change in velocity divided by the change in time. That's another way of looking at that equation. Something to keep in mind is that a small force that's exerted over a long period of time is going to produce the same change in momentum or impulse as a large force exerted over a short period of time. So remember, we talked about this before. If we can extend the amount of time it takes for the force to act, that's going to be a safer situation. So here, the crumple zones act to extend the length of time that the force is acting between these two cars. Instead of staying sturdy and stopping faster, we've extended that time by crumpling. And that reduces the force that is felt by the passengers in each vehicle. So to review things we've talked about, in collisions, force can be reduced in two different ways. In previous sections, we talked about work and energy. We can increase the distance required to stop, and that decreases the force. Or in this section, we talked about impulse and momentum. If we increase the time that's required to stop, that also reduces the force. So again, two ways that you can reduce force. You can spread the force over a bigger distance. You can spread the force over a bigger time. Both of those things reduce the force that's acting between two objects in a collision. Here are some practice problems for you to work on. There are problems for momentum and impulse. Please read the problems carefully, solve them in your binder, and then let me know if you have any questions. Thanks. Have a great day.